packet pushers.
Welcome to Day 2 DevOps, where the dev oops is in the details. I'm Ned Bellavance, and on Day 2 DevOps, we explore those details and how you can learn from the mistakes of others and build a solid DevOps practice on day 1 and beyond. With me on this journey of learning and doing is my co-host, Kyler Middleton. Hey, Kyler.
Hey, Ned. On this episode, we talked to Marcin and Joey about how Spacelift can glue any infrastructure as code tool together with another one, which can make migrations and integrations way less painful and manual, and how CI/CD tools like GitHub Actions, because I know that's what you're using at home, me too, don't fit perfectly with how infrastructure as code tools work, but Spacelift does, and how Spacelift has this unique capability, as far as I'm aware, of inventorying your resources deployed with infrastructure as code among all of your layers, but also what post-provisioning stuff like your Ansible runbooks have run on each item and which ones have succeeded and failed, which just makes your life easier.
Yes, and guiding us on this sponsored episode about being the glue of IAC is co-founder Marcin Wyszyński and solutions architect Joey Stout. Spacelift provides a platform that operates on top of your infrastructure as code tools, and it can help build the automation with and between them, creating graphs of graphs that make your dependencies just work. Please enjoy this conversation with Marcin and Joey. Well, Joey and Marcin, welcome to Day 2 DevOps. We're very excited to have you here. Let's start with, what is Spacelift? For folks who have not heard of Spacelift before, Joey, can you walk us through what it is and why it was built?
Spacelift, a lot of people, especially because of how we started, think of Spacelift as just a tacos platform, and that is not entirely the case anymore. We are a multi-tool IAC orchestrator, so we support things like Ansible, Kubernetes, Pulumi, Terraform, OpenTofu, all of the major things. We even support the cloud-specific IAC tools, so like CloudFormation, Bicep, things like that. What really makes us really powerful is we're able to take all of those individual tools and combine them together, which is something that we want to talk about here today. So you can build things with OpenTofu, spin up some VM, and then pipe that information over to an Ansible pipeline so that it can automatically configure that VM that was spun up in the cloud.
Okay, you made reference to an acronym of tacos. And for folks who aren't familiar with that acronym, what does that stand for?
Oh gosh, I know what it stands for, but I always just say tacos. So Marcin, do you know what that one is?
Terraform automation and collaboration software.
Yeah.
There we go. Okay, so a delicious taco combines that collaboration and automation for Terraform, but you're more than just that. That is the first thing I think of. Spacelift is Terraform and OpenTofu because that's where I discovered the platform and started playing around with it. What other tools do you see folks integrating? I think, Joey, you mentioned a few, but what are the most common other tools that people tend to bring into the Spacelift platform?
So we support pretty much everything. And what's really cool about Spacelift too is you can even bring your own IAC tool. So if you look at our docs, you can bring your fictional super IAC tool and it will run it through the Spacelift pipelines to, do whatever it is that you want to do to spin up some amount of resource. So what you're limited to, nothing. You're not limited to anything. You can use any IAC tool really. But out of the box, I think the two major things that we see our customers using is definitely like Terraform, OpenTofu, and Ansible.
Well, let's talk about that some more. So when I think about Spacelift, I think it's for Terraform, it's for OpenTofu. So how do you tie it together? Because I have certainly built these pipelines before that do that. You're tying Terraform to Ansible. It's annoying, it's fiddly. You have to get the outputs just in the right place where it can be piped in. How can I save time with this Spacelift? Because please help me save time. It's so annoying to write those things.
So I think in software architecture and software development, you very frequently think about layering. Solving the right problem at the right layer is what makes this solution reusable and what makes it feel right. What Spacelift does is it provides a layer on top of other tools so that those tools do the minimum that is specific to them. So with Terraform, there will be inputs and outputs For Ansible, there's going to be playbooks and lists of hosts, etc. But we basically take the minimum specific, and all of the services that we specify are actually running on top of it. The connectors are minimal. The touch surface between us and the technology that you might be running is minimal. That's how you can actually supply any technology that exposes that surface. What we then do is we provide a number of services on top of that. So, for example, stack dependencies that allow you to pipe the output of one stack as an input to another stack, something that, with Terraform you would do with external state references or remote state references, and then you do it differently with Pulumi, you do it differently with Ansible, and yet you have the same, because you're solving it at a different layer. You're not solving it at the layer of an individual tool. Then all you need to do as Spacelift is to build those tiny connectors to much larger shared services that we're supporting. So while yes, most users would use us with something like Terraform or OpenTofu, it is actually an implementation detail, because the value of Spacelift is in those shared services and the ability to do multiplayer mode and sort of graph of graphs problem, which is not really specific to either Terraform or Pulumi or CloudFormation.
I want to add on to that just a little bit. One of the powerful parts of Spacelift, I think, is that like we're not dictating how you use the tool. You use the tool like you do naturally. You use outputs from Terraform, you use variables inside of Ansible, and we're just able to connect those two, native concepts together.
I have kind of an example that I have had to solve recently, and I did it with GitHub Actions natively, and it was very annoying. And I'm hoping that you'll say, like, this is great. This works great on Spacelift. So it is best practice to split your Terraform code or your OpenTofu code into different layers. And one of the layers I always establish is the networking layer to build the VNet and subnets and route tables and stuff like that. But if I'm routing to a firewall, we almost always put the firewall in a different layer. So I need to build the network, but not build a route to the firewall. And then I need to build the firewall. And then I need to go back to network. And I can do that all with GitHub Actions, but it is incredibly fiddly and fragile. Is that something that I can more easily solve here? Please say yes.
This is exactly what you do with stack dependencies.
Oh my goodness.
Exactly, yeah. And then when you're changing one dependency, the other dependency kind of knows about it immediately. And then you can pretty much serialize your changes in a way that is aware of the topology and all the dependencies. Like, let's say with OpenTofu or Terraform, you have this problem of graph of graphs. Obviously, there is this concept of Teralith, where it's a word, I think it's a recent word, but the concept is as long as Terraform itself, where you get so excited with managing everything through code that you end up with thousands and thousands of resources, and suddenly you realize that, oh, like refreshing those resources takes ages, because like this is the logic of Terraform, that it doesn't maintain any state between like executions, right? It's a CLI thing. It doesn't listen to the world while it's not on, right? So it has to refresh everything. And when it's refreshing, like if you have thousands and thousands of resources, then it'll take ages and consume your quota and cause all sorts of problems. So what you do then is you split into subgraphs. And then you have a problem because you need to pass the data between the subgraphs. And if your upstream is changing, like how does the downstream know that it should update? Just having a reference is not enough. You need to have a reference that is kind of actionable. It's like in some programming paradigms, it might be called observable or signal. How do I know that something has changed? How do I react in response to that? It's like reactive programming sort of thing. And that concept is not well served in any tool that we've seen so far.
Yeah, in traditional programming, I would have like an event bus or something that when a change occurs on one portion of the subgraph, I would want to put that on the event bus. And then I would have other portions of the subgraph that subscribe to that event bus and go, oh, okay, there's a new message and it applies to me because I'm subscribed to that type of event. And that means I should do this. But like, there's nothing in Terraform or OpenTofu that has any of that kind of awareness.
It's a great point, Nat. Yes, it's ultimately there is a bit of an event bus, but it's an event bus in a graph environment where you can have diamonds, right? It's not just like a giant tree. It is a directed acyclic graph. You are guaranteed not to have cycles in there, but you might have diamonds. So it is not an easy problem inherently to solve, but it's an interesting one to solve. And that's what gets our engineers interested as well in building that sort of stuff.
And Spacelift just makes it super easy as well. You literally just say this stack does this thing and it goes and handles it for you.
It sounds like a graph of graphs. In the same way that you said earlier that it's solving the right problem at the right time. Of course, you should break your graphs apart because you don't want to have this like huge explosion radius if something goes wrong. But then how do you connect them? And this tool bridges the graphs together. It graphs the graphs. Love it.
Exactly, Kyler. It doesn't really matter what sort of graphs it bridges because it bridges them by the little handles that Spacelift provides, like inputs and outputs, for example, in OpenTofu. What's inside? Spacelift doesn't care. All it needs to know is that I need these inputs and I'll produce these outputs. And that's it.
When I speak to engineers about automating their IAC, the most common response I get is they're using a generic CI CD platform today. They're using GitHub Actions or like Azure DevOps or GitLab. They're using one of those that wasn't intended for IAC, it was just intended for CI CD in general. They like it because it gives them a lot of granular control. But I think, as Kyler sort of mentioned, there's a lot of frustration there as well because you do have to like build everything from scratch and figure out the weirdness that is IAC. So, what are the major benefits you see of someone moving over to Spacelift instead of just writing it all themselves in GitHub Actions?
In my opinion, like it's just really the maintenance side of things. You want to implement some feature that OpenTofu uses, you have to go through and, check all your hundreds of pipelines, make sure that they're all using some common, library that you've written and maintained to start using said feature. Maybe you want to import a bunch of things using Terraform's new import blocks. You're going to have to go through and change that code that runs to actually spin up that Terraform code to support some new feature that you might want to do. Whereas if you use something like Spacelift, you're putting that maintenance on us, and we're really good at making sure that we support all of the features of the native tool, so you can pretty much guarantee that once that new feature drops that you can start using it inside of something like Spacelift.
That's right, Joey. I mean, the way I look at it is ultimately it's the build versus buy dilemma. We build Spacelift, like we're coders, but we're not special in any shape or form. It's not rocket science. Like we're not building rockets that go to the moon, which means that you probably will be able to build a workable subset of Spacelift functionality within a couple of months or a couple of weeks, depending on what sort of functionality you need. And ultimately, what GitHub Actions is going to give you is just going to give you VMs to run commands on. And you probably run similar commands, or the logic is going to be similar to what we do. The difference is that, well, this is what we do. Your core business is probably different, right? So ultimately, are you in the business of building graphs of graphs and maintaining state between different executions and doing like collaboration and serialization, etc.? Or are you in the business of, I don't know, like delivering food? So ultimately, everyone could build it on top of anything they wanted. It's just the amount of complexity that you need to add. And if your team is really small, if your needs are basic, then I think you can go very, very far with generic Circle CI or whatever, GitHub Actions, Jenkins, whatever you can think of. I think you can go pretty far. And frequently, when I talk to customers who are not sure if they want to or need to use Spacelift, my initial reaction is don't. I mean, try to build something on top of generic systems and see where the trouble is, because maybe there is no trouble. Maybe you're there. Maybe it's exactly what you need. And then when they hear, sometimes they hear, okay, here's a catch, here's a catch, here's a catch. You go like, I think we're just going to go with something dedicated. It's a similar discussion with people who are using Atlantis, right? I know Atlantis very well, and I frequently help people set up Atlantis. Because if they can solve their problem using Atlantis, they probably don't need Spacelift. It's probably an overkill for them, right? But once they outgrow Spacelift, these guys will ask the exact questions that you're answering, and they'll understand the problems like this. Well, it's not even like we don't even need to pitch them, right? They get it immediately. Like Kyler asked, can you do this with Spacelift? And the answer is yes, you can. And then, the light bulb goes off and like, I get it. I get your value prop.
Right.
Can I give you a real world example?
Yeah.
I used to work for a company in Central Ohio, and we built a ephemeral environment API. Basically, we spent months and months creating this Lambda API that can spin up Terraform code that gives our developers boxes that they can fill in things like, what size VM do you want for your ephemeral environment and things like that. It was a really, really complicated process. If I had something like Spacelift has a blueprints feature which can ask for those inputs and pass them directly to a Terraform code. And then even better is at the end of the day, you can have Spacelift automatically destroy those ephemeral environments on some amount of schedule. Literally what I spent probably 6 to 8 months building, I could have built in a few hours on Spacelift because those features are just available and ready for me to use.
Wow. It's the sort of thing like you wish you knew back then. Would have saved you a ton of time.
Right.
Yeah. So if someone is currently kind of baking it all themselves, do you have tools or guides that help them migrate their current, GitHub Actions workflow over to Spacelift?
So we don't have tools to migrate from like self-hosted type solutions like that, just because everybody's going to build something a little bit differently.
Sure.
With that said, I don't imagine it being very hard. We do have migration tools for like the big competitor players. So if you're using one of our competitors, like we can definitely migrate you over using their APIs. But using something that's homegrown, like they could use our tasks feature to import state from something like an S3 bucket. We also have Spacelift as an API first product. So we have a Terraform provider.
Hmm.
You can Terraform your Spacelift account. So like what I've seen some of our customers doing as well is they'll write a quick script that can generate Terraform code so that they can just automatically have all of those new stacks, all of those new contexts, environment variables automatically created in Spacelift using our provider. And then all they have to do is run a quick task to import the state once it's ready to go.
We also have patterns for certain technologies. Like if you're migrating from Atlantis, we have like policy libraries that allow you to effectively replicate Atlantis workflow in Spacelift.
Oh, okay. That's good to hear. So once someone is on Spacelift, I mean, the automation parts sound pretty excellent. But one thing that I've heard more people being challenged by lately is a lack of visibility into the environments that they're managing. Like if you built this whole thing yourself with GitHub Actions and you've got like 20 or 30 different repositories, each of which is managing like 4 environments, trying to get visibility into what am I managing and what's the state of all of those different environments is super challenging. What sort of tools do you provide on the Spacelift side to make it a little easier to get that level of visibility?
So if we stick to OpenTofu or Terraform, every OpenTofu state is something like we call it a stack. It's a combination of code, configuration, and state. And then on a stack per stack basis, you can see the jobs that are being queued to potentially update the state, run any tasks. And then there are speculative runs. We call them proposed runs. So this is something that is done on a per stack basis. You can combine stacks into larger organizations or sub-organizations called spaces. They can be nested, so you can apply different rules depending on where in the space tree or in the organization tree you are. So you have this very tight control over what gets enforced where. And then apart from like having this deployment unit called a stack, Spacelift is also a resource catalog. So in a stack, you see what is that you're managing, and you can search for things that you're managing based on the space, based on account, based on provider, based on technology. There's so many different facets by which you can search that ultimately Spacelift is not a bad proxy for what you have managed using AAC.
Also, on top of that, too, we've been talking about Ansible a little bit. We have a configuration management view that builds on top of what Marcin just said, where when you're running something like Ansible, it's running a bunch of tasks against a bunch of different hosts. And if you have a failure or a skip, or you want to know what's exactly happening with a specific host, that configuration management view makes it really easy to find it because we list out the overall status of every single one of your hosts. So say one had one failed task, you could scroll through all of your hosts, find the red host, click it. It will then show you every single task and every single role that ran against that host. And it will give you a really nice way to just find that one failed task where you can easily see and find and debug the things that have happened with each of your individual tasks and hosts with Ansible. Whereas if you're using the Ansible CLI or something like AWX, you're digging through the logs and you're like, where is this failure at? It's a pain to find. Where a Spacelift, you just go to that one place, you click the thing, there it is.
I have never considered that use case. That's fascinating. for Machine's framing of it, that you want to see like which resources are deployed and where they come from. I've established like tag schemas, but then you have to maintain all those tag schemas across all your separate repos. Or maybe you have a module that just builds tags that you're needing to maintain forever. But in terms of like which post provisioning tasks have run against systems, I don't even know of a tool that would do that other than like a Microsoft SCCM Systems Manager or something just super heavy that only large enterprises might have. That sounds great. It sounds much more convenient and flexible.
Another use case of that too is I've actually used Spacelift as a customer. And when I was a customer of Spacelift, I worked in a regulated environment, and we actually used that resources view that we're talking about to create inventories that we had to provide to like the federal government, for example. So if they're like, hey, we want to see all of your security groups and the rules inside of them, I could filter inside of Spacelift to those security groups and provide exactly what they need without having to build like a bunch of custom tooling.
On that thought of, compliance and having to adhere to certain regulations, I believe you also have a policy engine that's included in Spacelift as well. Joey, can you describe what that policy engine is and how it's applied?
Yep. So we have a engine that is built on OPA with Rego. Is it Rego or Rego? I don't actually know that answer.
I believe it's Rego. That's what they say on the documentation. It's like ray gun, Rego.
Oh, okay. Learn something new because I always use them interchangeably, but it's in Rego. You write some Rego code. We have different policy types that do different things inside of Spacelift. Like we have a plan policy. So if you're running something like OpenTofu, it can interrogate that plan phase of the IAC run. And, say your organization has an organizational policy that you can't create publicly accessible S3 buckets. Well, you can have that plan policy, interrogate that plan phase, see that you're trying to create a publicly accessible S3 bucket, and then do some action against it after that. Ask for an approval, stop the run from happening, whatever you need to do. We have other different policy types like approval policies to ask for approvals, notification policies that can send notifications out when certain actions happen inside of Spacelift. And then what's really cool about our policy engine is that you can tie the different policy types together using policy flags. So you can take a plan policy that catches that S3 bucket, pass that information to our approval policy. The approval policy can then say, hey, when I see people creating publicly accessible S3 buckets, I need to ask the security team for 2 approvals before the run is allowed to continue.
Hmm.
And then it can pass that information further along to our notification policy and say, hey, notification policy, you need to reach out to the security team in Slack and let them know that there's 2 pending approvals waiting for them.
Wow. That's much more robust than just scanning a plan and going, oh, that's no good. You're building a whole workflow out there based off of policy.
The thing too is that like we don't care what IAC tool you're using. If you're using something like Ansible, we can run Ansible in check mode and then apply those exact same policies to it to make sure, you're not creating a 777 file on a server. Or, if you're using CloudFormation, you're using specific things in CloudFormation that you should be using. You can use our policies with every single IAC tool, even custom ones if you wanted to.
Right. I've used OPA before to scan, Terraform plans and whatnot, and also with Kubernetes. And basically, if whatever it is can emit JSON, then OPA can inspect that JSON and apply policies to it. That makes it super flexible. What I don't love is how hard it is to write Rego. So, do you make my life easier in that regard?
To some extent. We have something called a policy workbench where we capture the samples of the inputs to the policy and we allow you to play kind of offline without triggering anything. Like you can see how your policy would behave in response to like past inputs, right? And then you can apply the changes to the policy. As to, I think there is an interesting train of thought here, Ned, when you mentioned that you give it like Rego is good in the sense that you give it some input and it can inspect an input. But taking it to a slightly deeper level, you can say that Rego is also a great text transform. It's a great transformer of things. It's like the ancient technology XSLT. You'd feed that some XML and it would create some XML for you. In this case, you feed it JSON. It does some magical transformations and it emits or doesn't emit some JSON, which is really fascinating because it's not just a yes or no or maybe engine. It's really just a way of decoupling decision making from decision implementation. But decision making can be extremely extremely powerful. As in Spacelift, you have a number of different kind of entry points into what you want to customize, what you want to control, from a plan or from a push policy where you see, okay, well, this is the GitOps trigger of my job, to plan policy, which says this is what I'm going to change, to an approval policy that says this is who I'm going to notify, and how many notification policy, which says I'm going to notify those people, and then an approval policy, these particular people need to approve through these different channels. And then you can pass the state between everything that is happening there using policy flags. You almost have two parallel timelines or two parallel life cycles. One is the life cycle of a code change or a configuration change, and the parallel life cycle is of people and processes interacting with that life cycle. And these are kind of separate but interdependent.
In addition to the policy workbench too, Ned, we have policy templates.
Mhm.
So those are going to be Spacelift curated policies that we make available to all of our customers. And how that really helps you is like you can go in and find something that we might have curated that kind of fits a use case but doesn't exactly fit. You can import those into your account and then you can modify them to do, something a little bit more closer aligned to what you're trying to do. And we actually did have a webinar on this probably like 2 or 3 months ago at this point, where we went through the policy templates. We came up with an idea on what we wanted to do. We found something that very closely aligned to what it was, but not exactly. And then we just modified that policy to do exactly what it is that we want it to do. And that just allows, people that might not be super familiar with Rego to really jump into it and start using it right away with Spacelift.
Yeah. My challenge with Rego was the blank page problem where I'm like, I know what I want to do. I just don't know how to start. And then if you give me a starting template, okay, I've got something to go off of. And now I can build the thing I want.
I feel like a lot of people have that kind of like blank page syndrome problem with Rego. Personally, I hated Rego when I first started, but the more I use it, honestly, the more I love it. It's a really fun tool to just play with. Like, I've wanted to incorporate it into my own personal projects, even just because once you understand the like nuances of Rego and how it actually works, it is a little clunky, I would say, but it's still fun to play with. Like, it's just fun.
I know when we talked in the pre interview, you said open source is at your core. And I love that framing. I'm a big open source kid. I wanted to ask, like, how do you think open source platforms like Spacelift fit into the big picture for enterprises?
Marcin, the open source god, has this one.
Stop. I think Spacelift is glorified glue, and it wants to remain glorified glue. We want to allow people to use technologies that are well supported in the market, that are known to solve problems, that are freely available, that they would have used in their home labs, that they would have used in their student projects, they would have used in their previous jobs. We don't want to tie them into any made up standard. You know, this XKCD comic about, oh, let's create a standard. Like, there are 14 standards. Let's create one standard to standardize everything. And then you end up with 15 standards, right?
Mhm.
Think what open source is really good at. I'm not even going to go into this ideological layer because there's a lot in there as well. But from a purely practical point of view, open source is great because it standardizes people's efforts into a small number of larger projects and larger bodies of work, communities which support one another. They can speak the same language. Like, if you're thinking about infrastructure as code, then you have an open source, or you had an open source tool like Terraform. If you're thinking about like containerization and shipping applications in self-contained environments, then you're thinking Docker, right? And we'd be combining those tools to accomplish a certain set of useful tasks. Or, you're thinking about decoupling policy or decision making from decision enforcement, then open policy agents immediately comes to mind. And by the way, there are more tools, right? You could use something like, I think it's Q
Mhm.
language, CUE language. Some people suggested that we use that instead of Rego. I mean, we could. For us, it doesn't make that much of a difference. It's like as long as your tool does the same thing and accepts the same inputs and accepts the same outputs, like, it wouldn't be that much of an effort for us to support it. But there wasn't just too many people asking for it, which is the thing, right? We just allow people to use what they're good at and what is supported, what is well known. And we solve the problems for running it at scale, for running it as in multiplayer mode. What we frequently present as an analogy of how we operate is Git and GitHub. So Git is this open source, wonderful, well, complicated, but still a wonderful system that technically is a distributed version control system. Now, if you'd actually try to use it in a completely distributed fashion where you'd be sending one another diffs over email or over Slack or over, I'm not sure, IRC maybe?
Yeah.
Mhm.
I don't even know how that's supposed to operate. I mean, yes, technically it could work, but practically it would be an absolute nightmare, especially in a large organization. So now you have a multiplayer mode called GitHub, right? GitHub is a huge player in the open source industry, but GitHub itself is not open source. It's glorified glue for a number of open source technologies, but it's a different layer. That system operates in a different layer. And I think open source systems are great at this lowest layer of immediately solving the immediate problem, like version control. Whereas systems like GitHub or Spacelift, the multiplayer coordination server based systems, they are not easily open source.
Just to plug Spacelift, the culture a little bit too. Like I've been an SRE/DevOps engineer for the last 15 years at this point, and I will build something at a company and it will be this like super awesome thing. And I'm like, man, I really wish that I could share this with everybody just because it's so nice. It makes everything so easy to do. And I've never been able to do so because when you work for a private company, that's their IP, that's their decision on what you do with it. Working at somewhere like Spacelift, where more than majority of our code that we write day to day is open source and available on the internet. So if I build something really cool, I'm free to go ahead and share that, and I've built like a policy engine that builds what we call login policies. It's called Mr. Pickles, if anybody's interested in checking that out.
That's great.
It's an acronym. I can't remember what it stands for, but it's called Mr. Pickles. And I wouldn't have been able to do something like that at another company where, I built something really cool that had a really easy way of doing something and sharing it with everybody. And Spacelift makes that a priority. Everything that we build, if it's helpful, more than likely we're going to share it with the community.
That's awesome. I love to
Mhm.
hear that community aspect of things and giving back, because that's huge. And it also saves people a lot of time. you know, it's that build versus buy. Well, if somebody already built the thing and you don't even have to buy it, why not use it? Makes sense.
Right.
And the long tail of maintaining it forever, Ned, is something it's so easy to forget that, like, oh, now I built it. Oh, great, I'm done. No, you're not. This is the beginning.
So, aside from Mr. Pickles, what other cool things do you have cooking over at Spacelift? Is there anything interesting on the roadmap you'd like to highlight?
We're investing heavily in our integration with Ansible,
Hmm.
especially use cases that are Ansible first. So companies that would migrate or they would be in stages of migrating to the cloud at various speeds. For them, for our world now, Terraform is the present.
Hmm.
Some would say, maybe even like the bleeding edge guys would say Terraform is the past and X is the future for some value of X. Well, for a lot of companies who are primarily on prem, bare metal, Ansible is the present, and God forbid, it might even be the future. And it's like I can't remember who said that, but the future is already here. It's just unevenly distributed.
Hmm.
In a lot of companies, it's very unevenly distributed towards Ansible, towards on-prem, bare metal, the kitten computing, right? And we want to provide this bridge that has equally strong foundations on both sides of that river. So on the river of kitten computing with bare metal, Ansible, that sort of configuration management, and the new world, the cattle computing world of immutable AMIs and GitOps and Terraform, that sort of stuff, right? And you can't really cross that chasm unless you have a bridge. And we want to have that bridge that is equally good on both sides, equally solid.
Hmm.
So that's one thing on our roadmap. The other thing is it's actually very far into the future. My R&D team is working on something called, it's a working title, it's called Flows, and it's about automating day two operations. So like anything that doesn't lend itself very easily to sort of declarative management as you would do with something like Terraform or OpenTofu, which is more event driven. We're trying to turn day two operations like that, the automation, we're trying to turn it into product.
Hmm. That sounds fascinating. And since we are day two DevOps, we're going to have you back on when that starts becoming more of a reality so we can dig into what flows are. That really perked up my interest.
And we have this tradition of closing out every show's conversation with asking about the new frontier of AI. Does Spacelift have any AI features? Are you considering any AI features? What is your position there?
We do have a whole AI strategy, and we have a number of sort of test cases that we validate different models against to understand when are we going to be ready to release certain things. Because the way I look at Spacelift and our little corner of the world in what we're responsible for, we're like air traffic control of IT. Like if you make a mistake, that mistake is going to be fatal, and there's going to be clear responsibility for what code, what processes, and what humans were involved in making a particular decision. Letting AI make that decision without any human supervision is currently extremely risky, not only from the point of view of making mistakes, but also from what do we change about our process if the AI makes mistake, right? Do we upskill the person? Do we change the procedure? Do we change the tooling? It's unclear. So we currently look at fringes of our products to inject AI. So fringes would be like, if I have logs from an OpenTofu execution, can you summarize what happened there? Just give me a quick summary. Can you summarize what the error was and maybe show me in the code what could have been the source of that error? If I have a resource catalog, can you query that catalog with natural language? And these are the sort of like not on the critical path uses of AI, right? And I think for now, at least with our core product, we'll be on the conservative side of not putting AI on the critical path. However, we constantly have the number of test cases, and just today we've been testing two new models against those test cases with the exact same result as with previous models, which was a failure. However, I think at some point, maybe, we just need to keep an eye out and be pragmatic about it. But still, like, we have two constraints. Like, we have to be right at least 80% of the time, and it has to be non-trivial. If it's just pasting something into Chat GPT, well, that's not AI integration. It's just like a little gimmick. And sadly, that's what a lot of people call AI integration. Now, if that just involves sending the data to a third-party API, that's not so valuable. It can be convenient and we might do it, but we wouldn't consider that a competitive advantage or a big strategic play. It's not, honestly, let's face it, it's trivial.
Yeah, it seems that AI is excellent at summarization and everything else is kind of a beta feature at this point.
Yeah, it feels like when you show me a demo, it's like, oh my God, it's amazing, right? And then I try to do something in the system that I just saw, and I'm like,
Yep.
it's like I'm trying to repeat a party trick that you just performed, but I can't.
Yeah. I don't want non-deterministic infrastructure. No, thank you.
Yeah.
Completely agree. Well, Joey and Marcin, thank you so much for sharing all this knowledge about Spacelift and your nuanced approach to AI, which I think Kyler and I both very much appreciate. If you piqued their interest, where would you recommend they go to learn more about Spacelift?
Please go to spacelift.io if you don't know us yet. If you checked us out in the past, please go to spacelift.io again and see what we've been up to.
Yeah, sounds like there's been a lot of change, so definitely worth checking out. Joey and Marcin, thank you once again for appearing on Day 2 DevOps.
Thanks for having us, Ned.
Thank you.
Thanks to our guests for appearing on Day 2 DevOps, and virtual high fives to you, dear listener, for tuning in. If you have suggestions for future shows, we would love to hear about them. You can hit either of us up on LinkedIn or send some feedback via packetpushers.net/follow-up. You can find me, Ned Bellavance, at nedinthecloud.com, and my amazing co-host Kyler Middleton blogging over on letsdodevops.com. And we're both entirely too active on LinkedIn. Stop by, say hello. If you like engineering-oriented shows like this one, visit packetpushers.net/subscribe. All of our podcasts, newsletters, and websites are there. It's all nerdy content designed for your professional career development. Until next time, just remember that doing DevOps is awesome, and so are you.